Now we will speak about property number 2, the sum of vectors. How can I add two vectors? We will start with part A. We will divide the sum of vectors into 3 parts. The first one, the sum of two consecutive vectors. What's the meaning of consecutive vectors? Consecutive vectors means that AB plus BC, the extremity of the first vector is the origin of the second vector. Then we will eliminate B and it will be equal to AC. As you see here in figure, AB plus the vector BC will be the vector AC using Chassel's relation. We will take the starting point of the first vector and the extremity point of the second vector. It will be the vector. Now we will start with property about some of the vectors having the same origin. Here, as you see, I have the vector AB plus the vector AC. As you notice, the origin of the first vector is A, and the origin of the second vector is also A. So, what is the vector that is equal to the sum of AB and AC? Using the parallelogram rule, we will see that AB plus AC will be equal to the vector AD. What is the point D? D is the fourth vertex of the parallelogram ABDC. Using the two vectors AB and AC, we will continue the figure to obtain the parallelogram ABDC. The fourth vertex of this parallelogram, I will call it D. So, how can I name the parallelogram? Please pay attention for this remark. AB and AC are the two vectors that I will use. I will cross the origin of the second vector and I will place it with the point D. So ABDC will be the parallelogram that we will use. Now, we will speak about the last case, which is the sum of two opposite vectors. The vector AB plus the vector BA is equal to the vector AA. Using Chassel's rule, we will remove the origin of the second vector and the extremity of the first, and the answer will be AA. Also, the vector AB plus the vector BA, AA is a zero vector. So here, we will say that the sum of two opposite vectors is a null vector. Note, if AB plus BA equals zero vector, then I can say that the vector BA is equal to minus the vector AB. Or also we can say that the vector AB is equal to minus the vector BA. Now we will start here a small application. I have 3 operations I want you to simplify using the rules of addition of vectors that we illustrated before. The first one, the vector AB plus the vector CD plus the vector BC. Here I want you to pay attention for something. The most important thing that we will use in order to understand how we simplify these operations is that we place every two vectors where the extremity of the first is the origin of the second beside each other, where we can use Chassel's rule that we explained in property number 1. That is here I will rearrange the vectors, the vector AB plus the vector BC plus the vector CD. The vector AB plus the vector AC, using Chassel's rule, it will be the vector AC. And I will keep the vector CD. The vector AC plus the vector CD, using Chassel's rule, will give me the vector AD. Yes, you have a question. Can I add here the vector BC plus the vector CD and keep AB? If you try to do this, you will get the same answer exactly. The vector BC plus the vector CD using Chassel's rule is BD. Adding it to the vector AB Also, the answer will be AD using Chesel's rule. You may try the second way. We will start with the second operation. Vector AB minus the vector DC plus the vector BA minus the vector AD plus the vector AC. First of all, the most important thing is that I want to get rid of all the minus signs. We can replace minus vector DC by its opposite, which is plus the vector CD. And minus the vector AD, as we said previously, is equal to plus the vector DA. It's very important to get rid of all the opposite vectors which give us zero vector. It will make this operation much easier. So I will place here the vector AB beside the vector BA because I can apply here Chesel's rule. The vector CD plus the vector DA and plus the vector AC. I place the vector CD near the vector DA also to apply Chesel's rule. The vector AB plus the vector BA, these are two opposite vectors, will give us zero vector. So I will cross them. Using Chesel's rule, between the vector CD and the vector DA, I will get the vector CA. So I will get here the vector CA plus the vector AC. Vector CA plus the vector AC will give us zero vector exactly because they are opposite vectors. The third operation, vector AM plus vector MF plus the vector AF. You see here, I will solve the first two vectors. I will add the first two vectors. Vector AM plus vector MF using Chesel's rule will give us the vector AF. So I will get vector AF plus vector AF. Simply it is 2 times the vector AF. Now we will start with the last objective in this part, the translation of a point. As you see here, I have the vector AB and the point C. I want to place the point D, which is the translate of the point C by the translation vector AB. It is as if I move from point C to the point D in the same direction, same sense, and I want to move at the same magnitude. That is, the length of the segment CD must be equal to the length of the vector AB. So here I will get the point D. From translation, I will deduce that the vector CD is equal to the vector AB. Since by the conditions of translation, these two vectors must have the same sense, same direction, and same magnitude. So also we can deduce that AB DC is a parallelogram.